This is Parker Hannifin's Purpose in Action podcast. I'm your host, Annie Murmann. Imagine walking through your neighborhood on a clear morning, the hum of an electric refuse truck quietly collecting the trash. Perhaps you notice a bucket truck silently working on the power lines up ahead. These vehicles, equipped with cutting-edge electrification technology, are becoming more common in our daily lives. They represent a significant step towards cleaner air and a more sustainable future, a movement that's gaining momentum for all of us. Today, we dive into the story of Parker's global vehicle motor and its journey towards electrification. We'll hear from Stuart Goodnick, an engineering manager at Parker, who has been at the forefront of this transformative effort. Parker, a leader in motion and control technologies, has been pioneering the development of their global vehicle motor, or GVM, to meet the growing demands of electrification. Stuart Goodnick has witnessed and guided much of this journey. Here's a glimpse of how it all began.
I've been with Parker probably a total of about 20 plus years with a couple installments. It was one of the first jobs I had out of school, and it was really a wonderful place to learn some of the fundamentals about engineering. After a brief hiatus in another industry, I returned to Parker in 2012 as an engineering manager for our electromechanical division. And at that time, we were just at the beginning stages of developing a family of global vehicle motors. Our division had a long-standing presence in industrial motors, that is, motors that are serving factory automation. But the team was starting to find that there were more and more interesting applications emerging at that time.
The team at Parker realized the potential of their industrial motors in new and innovative ways, especially as the world started to embrace the shift towards electric work vehicles. The concept was simple yet ambitious. Adapt their robust industrial motors for mobile applications, specifically for vehicles that required both traction and work functions. Stuart explains how they began to see the market evolve.
So the global vehicle motor original conception was really being applied first for applications that are known as traction applications, where you're trying to move a vehicle forward. Today, we're very familiar with this with things like electric cars in the consumer market, but Parker's sweet spot has always been in a more off-road industrial space. So in addition to the motors for actually moving some sort of construction vehicle, there's also the need for what's called a work function. And so a work function, particularly in Parker's experience, typically involves the use of pressurized hydraulic fluid. And in a conventional internal combustion engine design, like a diesel engine design on a vehicle, how that's achieved is by taking power off the transmission and driving a pump. And then that pump pressurizes the fluid, and then you're able to do things like expand cylinders and cause boom arms to move on excavation vehicles. What we're able to do is to apply an electric motor to a pump and do the same kind of work, only now the power is coming from a battery system or potentially from a fuel cell.
This shift wasn't just about moving vehicles, but also about enhancing their functionality. Imagine electric buses transporting school children with no harmful emissions, or agricultural machinery operating quietly and efficiently in the fields. Parker's GVM motors started finding applications in everything from refuse trucks to electric buses, electric tractors, and construction machinery.
One of the exciting developments that we see, and we've worked with a couple of different startups in this capacity, is the electrification of tractors. Electrification is providing greener solutions for agriculture, but on top of that, with the electrification also comes adjacent technologies like electronic controls, data gathering and transmission of data over wireless lines, as well as autonomy. And so there's interesting developments here where electrification, autonomy, electronic control of the vehicles are all coming together to create a very different vision for agriculture in the future. And then in addition, one of the active areas for us for developing applications is mining. They've been actually an early adopter for electrification technology, primarily driven by the need for ventilation in the mines.
To optimize the performance of these electric motors, Parker developed the global vehicle inverter. Stuart elaborates on how this innovation came about and its significance as part of a comprehensive system solution.
As the market began to mature, the smaller players that were providing adjacent technologies like inverters were being acquired. But also we found that the customers really wanted to have a single solution from one supplier. So 3 years ago, we brought together some of the best and brightest people within Parker to really look at how we could develop an electronic inverter, a power converter that would optimize the performance of the GVM motor. And because we own the full scope of this system, we're able to use our control expertise to really optimize performance and to maximize efficiency, in particular, of a hydraulic pump solution. And this allows us to create modular and packaged products that we call EPTOs, and that stands for electronic power takeoff.
EPTOs are a critical electrification technology. They allow conventional vehicles, like bucket trucks, to operate work functions using battery power, reducing emissions and noise pollution in residential areas. And as regulatory pressure increases and acceptance of electrified technology becomes more widespread, these solutions enable Parker customers to bridge the gap between partial and full electrification.
It's not just fully electric vehicles that need an electronic power takeoff, because you can have a vehicle with an internal combustion engine, like a diesel engine, and a battery-driven EPTO in order to do the work, in order to minimize the emissions footprint of that vehicle when it's doing its primary function, which is work. For instance, a bucket truck or an aerial lift truck can drive with an internal combustion engine to a job site, but when it's doing its work, you shut the engine off, and you then use the battery power to actually lift the boom and do your work. That's actually very important because there's legislation like anti-idling that actually require on-road work trucks to have this kind of capacity, particularly if you're working around a residential area.
So what drives Parker's innovation? At its core, it's about a commitment to sustainability and decarbonization, a better tomorrow. Stuart shares more about this vision.
Parker organizes the company to articulate key purposes that we seek to serve. One of those elements of the vision is decarbonization, and decarbonization can take many different forms. The form that it takes in the context that we're talking about is in developing products and services in support of electrification. Every sale that we make, every application we make is contributing to decarbonization in the world.
It's clear that for Parker, solving customer problems and providing real business value is important, but so is making a positive impact on the environment. This commitment to purpose and sustainability not only drives their technological advancements, but also inspires the engineers behind these innovations. Imagine how this commitment translates into cleaner air in our cities and quieter, more efficient machines improving our daily lives.
When you can improve the quality of the air, you're improving the quality of lives. This is something that affects everybody together because the air we breathe is a common resource. These kinds of outcomes, these kinds of technologies actually drive better quality of living for everybody.
Stuart's message to young engineers is equally inspiring. He emphasizes the importance of finding purpose and meaning in their work, especially in fields like engineering, where the potential to impact the world is profound.
We all need a reason to do what we do, and purpose gives us meaning. And so when we have a sense of meaning, we can bring all of ourselves to the problems at hand. For me personally, the work with electrification and all the benefits that we've been talking about gives me a sense of urgency to solve these problems and to deliver quality products to market because I know it'll make a difference.
As we look to the future, the role of electrification in various industries continues to grow. Parker's journey with the global vehicle motor and their commitment to decarbonization exemplifies how innovative engineering can drive us towards a more sustainable world. Each electric refuse truck, utility vehicle, and piece of machinery represents a step towards a cleaner, quieter planet for us all.
It makes me proud to work for Parker because here you have a company that is defining itself in terms of these large, major problem areas that it's trying to solve to affect outcomes for humanity. And so it's not just about the financial statements. The financial statements are means to an end. What it's about is why are we doing what we're doing? And I think Parker provides an inspiring answer to that question.
Stuart Goodnick is the Senior Principal Engineer for Parker's Electronic Motion and Controls Division. Stuart, thank you for joining me today on the Purpose in Action podcast.
Well, thank you. I've had a great time, Annie. I always love talking about this stuff, as you can tell.
If you enjoyed this episode, be sure to subscribe and stay tuned for more stories on the cutting edge of technology and sustainability. Until next time, this is Purpose in Action, and I'm Annie Murmann.